Hello and welcome. We're going to talk about Houdini organizing and managing. So from a request, I wanted to make a video that talks a bit about how to organize a Houdini file, manage your tools. So the first off is, let's say you already have this Houdini file, I just have a box, and you can actually make a project. So if we go here to File, we can set and make a new project. So here, for example, if we make a new project, we will give it a name, we give it a path, and it will actually create all these type of folders by default. So if you need to save a lot of different structures and data, you can see it will create all this for you. You can even add your custom ones as well. So when I click on accept, it will place that in that location and it will automatically use this data. So especially what this job can also do is you can have this global variable called now $job. So this will automatically, if you use this somewhere in Houdini, it will automatically reference to your job save location. So if I say job at geometry, I will now automatically save to geometry, for example. You can also check out other variables going here to edit, and you have here the menu aliases and variables. These are some variables you can use to define locations. Now, what I personally use more is I don't always create a project. This is not something that I do every single time. But what I will do on a regular basis, let's say I want to export this box, I will just use the default like it's in here. I will use a hip-based save. So I will just type in $hip and then output. Or usually what I will do is $geometry.output, and then I just click save, and then it's then saved in your hip save location. So this is your Houdini file. So where the Houdini file is, I will also add a new folder called geometry and then output an FBX file. So those were some few things on setting up a file and exporting things. If you do work a lot with simulations and caching, you can also make sure that your cache file here can also use the hip file location or geometry, or sometimes I will rename this to cache, as it's sometimes a bit more clear that this is just cache data. And also if you would work with a PDG, like a top network, so here if we go inside this node, you can see that this is also again based on the hip file. So these are all based on hip file location. So if you're working with a job, you can always change this to job or something else. You can also make your own paths in theory. If you have like a custom project and you want to just create your own save directory or GitHub or Perforce, nothing is holding you back to make your own like custom variable or directory instead of using the hip or the job. Let's talk about general node network structures and tools to help you out with this. So you're building a small network like this. This is from a demo that I did recently. Maybe I shared a tutorial on that as well. So now how can I make some more structure? The first and obvious thing is, of course, the general layout and order of your nodes. You can use the L key to automatically place them, but usually that can go a bit funky. As you can see, it's not that readable anymore. You can also do Shift L by selecting a node and pressing Shift L. It will only arrange the nodes that are selected, but still you can see it can do some strange things if you leave, for example, these unused nodes around, like if you're still prototyping things and experimenting. So what I will usually do is I will hold the A key, and you can see your mouse will change. And I can, for example, now, let's say I want to align this nicely. I can, for example, put this on the side, hold the ones that I would like to structure, hold the 8 key, and drag the direction that I want to clean. So the selected nodes and holding A means that we can now, as you can see, control them in a direction. So if I move to up, they will stack up. If I move to left and right, they will stack up left to right. So usually you can see this, I will do this often in my tutorials, is I will just select the A key and then make sure everything is structured. Then we also have the wires. So when you see wires, we can press Shift S to control the way that they're connecting. So this is almost like a direct connection where it doesn't bend too much. And if we press Shift S, it will have more like a very curvy shape to it, like it will really curve nicely. So I usually use Shift S to make this more readable. Another trick that you can use is you can place these dots. So if you hold the Alt key and double click or click, you can place these small little dots and you can direct the lines a bit more like so. So in case you want to bring in that structure, let's say, for example, I don't like how this line is connected. We can, for example, bring it on the side here. And we can redirect that line if that's something that you really want. We can, for example, do it like so as well. And then, of course, we have then the nodes itself. So I talked a bit about the general nodes layout and wires, but we also have the shapes and colors of nodes. So here at the top, you can find some elements to help you out. So here we have color. So if we press the color palette or the C button, we can color nodes. So let's say I want to have this wrangle, and this wrangle needs to have the color red or something like that because it's a wrangle. You can simply do that. So you can build up your own coloring system to make sure that sometimes it can be easier to read from a distance how nodes are colored. Now, if you ever use the side effects lab toolset, like for example the fast remeshing or other nodes, you will see that they will use some color coding. So this can sometimes be simple, this can go sometimes advanced, but you can see like all these wrangle nodes are in this pink color. Now, when it comes to the node shapes as well, we can press the shape button or the Z button here, and then we can just use a different shape. So let's say this is my output. I can, for example, use this. So very quickly changing that. I don't use this all the time, but definitely quite useful to quickly make a difference in shape. Let's say we need to give this a special shape. We can just quickly give it different shapes and styles. You can also see above here that we have more options. So this will be a subnetwork box or Shift O. This is adding, so let's say you're selecting a couple nodes and press Shift O. It will make a nice frame around those nodes, and we can type in a certain logic here. So in my case, this was the logic for scattering these small rocks. So this would be for me rock scatter tool or rock scattering. This is now being its own nice system. I can do the same here. This is probably for some of the tree scattering that I did. So I can do the same and say tree scatter tool. And that way you can just continue. I can make a frame around this, make a frame around this. We can just keep these small little frames because usually I will do frames around smaller logics, so just to group them and define them, especially if you would work with a bigger network. It's nicer to have like these boxes defining how parts are interacting with each other and how they are laying out. Now we also have here the sticky nodes, which is Shift P. So in case you would be sharing this file with people or in your studio, sometimes it's useful to define a little bit more than just saying this is a rock scatterer. You can maybe do some more summary about this is rock scattering using this technique, or these attributes are important. You can try to mention more essential data, or you can just generally use this as like a to-do list or a bug list or something you want to do. Like, hey, I want to include more features in the future, and I'm going to just write them down here, or I'm going to write down my bugs so you can just see it here as well. So just general useful to have something to quickly type upon in the network. You can also here place an image. I don't use it that much, but if you really want to import an image, you can just click on this image button and it will ask you to open an image and I will place it for you in the viewport. Then we have subnetworks. So here we have a subnetwork. So a subnetwork by itself is nothing special. I can also just type it here. I can type in subnetwork. So this by itself doesn't do anything. It's just a node where you can just place other nodes inside. So you can also make then an HDA from this quickly. You can say create HDA. What I would use subnetworks for is usually with bigger networks and systems. So this node or this network is not maybe the biggest one, but let's say this network was like 10 times bigger. Then instead of using a frame to say that this is my rock scattering tool, I will just use a subnetwork. So Shift C. And I will just define it like that. I will just say that this is my rock scattering logic. And I will do the same with the trees. I will just grab this into a network and then say that this is for the trees, for example. So that's how I would handle subnetworks. If again, this is mainly when I work with bigger networks or bigger logics, I will usually break them down into their core systems. And if it's useful, we can make this into a new HDA. But if it's not really useful, I just leave it like this because it's just more useful to look at the network that's a bit smaller. So here I can now quickly see that this is for the trees, this is for the rocks, and I can just dive in and dissect the graph or improved graph. And that's how I would use subnetworks. Now let's talk about HDAs. How do we manage and structure them a little bit more? I've already talked about shapes, colors, node networks, things like that. So the first thing that I want to show before I want to show anything else is how can we easily assign like a default color or shape to this node. So this is a custom HDA that I made, just text boxes. I can just right click and go to the properties. And what I want to do is on the script section of this node, I want to create a new script that says onCreate. So when this node gets created or spawned, we can, for example, set a color and a shape. So you can do it in this way. So we have here the color thing, basically Quarks node, which basically means look at yourself, like the HDA itself. And then we use the function set color and set a color, which will be a red color, of course. Then we can do also the same for a shape. We can say Quarks node itself, and then look at or set user data, which means we want to set the node shape. And this can, for example, be a wave. So you can use also the other names. So you have to look it up which ones are there, but you can set all these basic shapes because they have a certain naming to them. So if I now press apply and accept, by this node itself won't happen, but every time I will now place that stacking node, it will have the red color with the wave. So this is how we can set a base color or default color or code the value. We can also do other things because it's literally like a small Python scripting place to do elements. So we can do other elements like setting a value or do other tips and do other tricks. But here we can just force it to be using to set the color of the node and the shape of the node. Now, the other part about an HDA is, of course, when we make an HDA, where to save them. And this directly relates to what we call in Houdini packages. So packages is nothing something new, but basically a package will tell where other tools live. So a package basically tells like, look at my custom location, could be again GitHub or Perforce. So for making packages and handling packages, now how is that done? So you go to your documents, your Houdini, and then packages. If you don't have a packages folder, you create one with this specific name, packages, of course. Then you can make a JSON file, and in the JSON file, we will basically describe where tools live or where we can find certain tools. Now here is an example of what I made in this package. So first of all, we have the path. We have load package once, which says set to true, and then we can also enable based on Houdini version. And then more importantly is we set the environment path. So we make a new variable sort of saying that my package is located at my D drive / my package. So basically when we say path, it's referencing my package, which automatically means this value here, which means look at the D drive. So at my D drive, I have a folder called my package, and in there I will then store my HDAs and other tools. You can make a whole folder structure, all these kind of things that you would normally do when you would make packages and structure. And once you are creating this package file, you probably need to relaunch Houdini. So I already have it, so I don't necessarily going to relaunch Houdini, but you probably need to relaunch Houdini. And if you want to double check that your packages work, we can go to Window, HScript export, and we're going to type in echo and then $, and then the name of your package. So in my case, it was my package to keep it simple. And when we press enter, it should return the location where this basically reference to. So if it returns your location, if it's somewhere else, if it's on GitHub or something, it will then return where your GitHub files are on your computer. So this way we can quickly see if it works. So just saying echo.yourpackage. So we can actually use this now to also save out other files and variables or to make an HDA. So if I would now make an HDA, let's say geometry, let's make something simple like a tube. Let's say I want to make an HDA from this tube. We're going to use a subnetwork, right click, we say create new digital asset. And the first thing that we can try to do here is we go to our path library. We can go this, set this to custom, and we can just use our value now called my package. And you can see that this will now store my tools or the tool that I'm making into my package files. So we can give this a name like tool, it's just tube, so tool tube. We can also give the tool tube over here. We can also have a menu entry, so I can make this, give it this special entry. Like we can use my package, for example, like so. And we can give this a version, we can do all these kinds of things, but basically we will now store this into a custom location. And instead of storing our tools in your documents, we will store it now on a location that I'm going to decide based on, of course, this value. So let's just create a tool. And you can see again, it's creating my tool under my D drive. And we can now see in the tab menu as well, we have something which is called my package, and we can see our tools. So this way we can build out our own network of tools and organize them. You have the same with the labs toolset. So if we go here to, let's say the labs toolset, you have a lot of them, but they also do categories like character, geometry, world building. So they have some structures in them as well. And we can, of course, do the same thing here with our own packages. It's just a matter of adding an additional slashes and hierarchy elements. Now, the last few things that I want to mention, I just put under utilities. So just a few other small tips and tricks to make things a bit handier. So what you can do is you can also use Quickmarks or Quick View. So we're going to press Ctrl 1. Let's say I, for example, would now go to my output, and maybe there is like some rendering or FBX nodes here. Maybe we do, for example, like some rendering, and we're going to say Ctrl 2. So now we set these quick marks. So whenever I press 1, I will jump back to my graph here, and whenever I press 2, I will jump to my rendering network. And this can be very useful if you have this complicated network with a lot of different nodes structures. So usually this can be useful for PDG as well. If you work with PDG and you quickly want to switch to your sub-level systems, you can just press 1 and 2 to quickly go to these networks. So that's a useful thing to use. And what we can also do is, of course, using Control F. So in other software, this will work as well. Just using Control F to find something. Let's say I'm going to look for a BLAS node. So I don't have any BLAS node right here, but if I search for children options, I will basically now loop in or look into these subnetworks as well. So if you want to loop over or look over only what you have here, or if you want to look into like these subnetworks, you can enable that. You can also add specific filters. So you can see that we can have another additional filter for naming parameters, raw parameters, snippets, states, types, all these type of things that if you really need to like fine tune something or find something specific, you can use these filters. This all depends, of course. If you already started with a structured network, then things can be easier to find. But yeah, you can just quickly find nodes this way. Then something else also interesting is viewing dependencies. So when we have this graph, it's difficult to see which nodes use data from each other or which node depend on each other. So we can go to view and we can say here dependency links. We can, for example, say only on the selected nodes. So we need to select a node and then we'll view the dependency, but I'm going to just say show all dependencies for all nodes. So if you have a more complicated network, this might get blown up, but here I only have these two examples that are, for example, dependent or linked to another node. So if you, for example, use an object merge node, you can see that this node references to a specific other node. So it will show this line over here, and it will basically say, we'll put this over here for a moment. You can see that this is now sort of like a linked in the background. So these two nodes depend on each other. So if I were to delete this basic coloring node, that means that this node will basically not work properly because it was dependent on that node. Also, if you would link parameters together like I did here, you can see that this box basically references the grid 2 and its size. So that means that these are, of course, also linked into each other. So they share data, or I mean, the grid shares the data from the size to the box. So again, if this node was suddenly gone, that means that this parameter won't be able to function like I want it to be. So that's why it sometimes can be useful to view our dependencies before we start to removing or deleting or reworking our networks. And then the last thing that I wanted to show you is the display of icons. So when we press the D button in the viewport here, we have this button, we have this menu to change some of our styles that we have here. But what we can do is we can also have these badges, and we also have these context specific badges. So sometimes, for example, here the error badge. So let's say I will place a wrangle here in my system and I just fill in something random like 1, 2, 3. It might, for example, here cause a error. So the icon of these errors can, for example, be set to normal. So it will be small, or we can even hide them. But of course, I don't recommend that. So we can set them to large. So in case you're looking for something specific, like we want to exaggerate the warnings, we can set the warnings to large, for example. So if I have any warnings, so here I had a big warning because I'm merging multiple attributes together, so this will give a warning. I will now easily see that this actually will give a warning. So what I will sometimes need is here is using the non-compilable icon. So when we make a compilable system or compilable loop, we want to quickly see if it's possible or which nodes are not compilable. So we can set this to large, for example. So here I can see that, let's say I want to make this into a compilable system, so it runs faster and bigger. We will have issues here with these two nodes. These are not fully compilable. So we can look into the network and we can see that this node right here doesn't have fully support to be in a compilable system. So that's I would sometimes use to just quickly see from a glance away. So it's easier to see from a distance to see if my network is able to compile. Because again, sometimes it is important to think about maybe using a compile loop to win some speed if you work with large data. And you can also use this for other things. Like you can see there are a bunch of different badges you can use. Like you can also, for example, exaggerate the HDA locking badge so you are aware of it. So let's say I want to, let's say I put that stacking node here again, and if I would now say allow editing, we can now have this big red lock button instead of the small lock. So we can change that. And again, this can be helpful to say that this is my HDA that has been unlocked, because that's also important to keep in mind that locking and unlocking HDAs need to be carefully thought out. And that was it for this video. I showed you a bunch of different things to do some managing and structuring of your networks and tools. So hopefully this helped, and see you in the next one.